Hi there. So we're going to work on part 3 of trajectory motion, and in this video I will basically do all of these problems right here. Let's get started. Number 1. A particle is moving and its velocity is expressed by this equation where t is in seconds. What is the average acceleration between 0 and 2 seconds? To find the average acceleration, you use the equation average acceleration equals final velocity minus initial velocity divided by change in time. Now the only things we don't really have is the final velocity and initial velocity. Since the time is between 0 and 2 seconds, our final velocity will happen when t equals 2 seconds because that's the later time. So the final velocity will be this equation plugging in 2 for t. So it will be 40 minus 4 times 2 squared, and the end result should be meters per second. Now to solve this, we will end up getting 40 minus, and then 4 times 4 is 16 meters per second. Now that will end up giving us 24 meters per second for the final velocity. To find the initial velocity, we do the same process, except we plug in t equaling 0. So we should get 40 minus 4 times 0 squared. And the end result again will be meters per second. That will give us 40, because 4 times 0 is 0, and 40 minus 0 is just 40 meters per second. Now we can plug into this equation. So the average acceleration will equal the final velocity, which is 24, minus the initial velocity, which is 40. They're both the same units, so I can just go ahead and attach the units at the end, divided by the change in time. We were going from 0 seconds to 2 seconds, so change in time is final time minus initial time, 2 minus 0, which is just 2.0 seconds. Now I expressed with significant figures 2.0, and I'm assuming that these significant figures are correct at any point, so I'm just going to go ahead and use whatever I plugged in for time. So my final solution should have two sig figs. So 24 minus 40 should give me negative 16 over 2.0, which will give me negative 8 meters per second squared. And the reason why it's meters per second squared, because this is negative 16 meters per second, that was seconds on the bottom. Meters per seconds divided by seconds is meters per second squared. Let's move on. Number 2. A car is accelerating while driving 20 meters per second at 5 meters per second squared. How long until it is driving at 343 meters per second, which is also the speed of sound? Keep in mind that this acceleration is constant. It will always be 5 meters per second. We can easily use the three equations. Since I'm looking for time and I'm giving the initial velocity and acceleration and the final velocity, I can easily use this equation right here. Final velocity equals initial velocity plus acceleration times time, which will give me 343 meters per second equaling initial velocity, which is 20 meters per second, plus acceleration, which is 5 meters per second squared, times time, which is something we're looking for. Now we can just solve it out. So 343 minus 20 is just 323 meters per second, which would equal 5 times t, and the units here is meters per second squared. We can see that these will cancel out, this will cancel out, and this will cancel out, leaving us with a unit of seconds, 1 over seconds. Solving for t, I divide both sides by 5, but let's also divide by 1 over seconds, and then you'll see that 1 over seconds will give us a result of seconds. Let's take out our calculator. So over here we have 323 divided by 5, and that will give us 64.6. So our time is 64.6 seconds. Now my significant figures would be just 1 because of these numbers right here. So my time would have to be 60 seconds. Because I have to round down. Now, this is how long it will take me to go from this speed to that speed. Let's move on. So Iqbal throws Jesus in the air vertically with an initial velocity of 100 meters per second. Now, how high will Jesus rise? You gotta understand, when you throw something in the air, gravity will continuously push it downwards, which is causing it to actually stop right here and change direction. So because of this constant gravitational field, we are going to have an initial velocity of 10 meters per second, but also a final velocity of 0 meters per second. The third equation uses everything that we pretty much need to know and will give us how high he has gone. It is final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. Now the final velocity, as we talked about, should be 0 meters per second squared, so that's just 0. The initial velocity was 100 meters per second. If you square that quantity, that should be 10,000 meters squared per second squared. Plus 2 times gravitational constant, which is 9.8 meters per second squared, times displacement, which I'm just going to go ahead and call it x. So in order to do this, we solve for x, take the 10,000 to the other side, so x should equal 10,000 divided by, and then 2 times the gravitation constant, which is 9.8. Now the units you'll see should end up being aligning in order to get meters, because this guy was meters squared per second squared, this guy was meters per second squared. You see that the second squareds cancel, this meter and one of those meters cancel, leaving us with a resulting unit of meters. So let's take out our calculator once again. So you're going to have 10,000 divided by 2 divided by 9.8, and that should give us our solution, which in this case is 510.2 meters. How far did Jesus go in the air when Iqbal threw him? It would be 510.2 meters. Now, looking at significant digits, when I made this problem, I wasn't too worried about significant digits, but I have to respect the fact that the velocity only did have one significant figure. So I'm going to estimate this to be 500 meters, because that's all the significant figures that I have. So that's the first part of the problem. Let me go ahead and erase all this stuff. Alrighty, part 2 says how long until Jesus hits the ground? Well, I have initial velocity, I have gravity, and I'm looking for time, and I essentially know what the initial and final position was. The initial position happened at 0, and the final position happened at 0 as well. So if you look at this, and you are looking for time again, right, then you can see that this will qualify everything that we need for the second equation. The second equation looks like displacement equals initial velocity times time plus 1/2 acceleration times time squared. If you have all these quantities, the only thing missing is time. Displacement, 0 minus 0 is just 0, which equals initial velocity, which we have is 100, I forgot to write it down there, 100 times time plus 1/2 times acceleration. That will give you a 4.9. Keep in mind that the acceleration is negative, so you should put a negative 4.9. And then we have time squared. This is a quadratic. We can simply factor out a t to make things look prettier. So we have 0 equals t, and then in parentheses 100 minus 4.9t. Now a displacement of 0 occurs at 2 times. The first time is t equals 0, and that we get from this part right here. The second one we have to solve for. 0 equals 100 minus 4.9 t, subtract 100 on both sides, and we will get t equaling negative 100 divided by negative 4.9. Again, let's take out our calculator. So we're going to have negative 100 divided by negative 4.9, but I can simply say 100 divided by 4.9 because the negatives do cancel out, giving us a time of 20.4. Again, I only have one significant figure, so I'm just going to go ahead and use 20 seconds. So it took him 20 seconds to fall down. So let's write that down. So our time is 20 seconds. That is it. Let's move on to the last problem, and then we're done for today. Alrighty, so Mr. S dared to jump off the 20-meter high jump board at a public swimming facility to impress a girl. Now, obviously, that girl is Mrs. S. How fast is he falling right before he hits the water? Well, we have a displacement, which is 20 meters. But if you think about it, I started off at the top, landed at the bottom, so the displacement really is negative 20. The final position is 0, initial position is 20. So the displacement is negative 20 meters. Now, what else do I know? I know the gravity is negative 9.8 meters per second squared. And what am I looking for? I'm looking for final velocity. Now, my initial velocity is 0 because I didn't get an initial velocity when jumping down. I just kind of let myself go. So my initial velocity will be 0 meters per second. The equation that pops into my mind is the third one. Final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. Let me change the color and let's plug in for numbers. The final velocity squared is what I'm looking for, so I'm going to not put anything in there. My initial velocity squared is 0. My acceleration is negative 9.8 because we're on Earth. And the displacement is negative 20. The reason why I tend to be very confident is because I can really look at these units and see that meters per second squared times meters will give me meters squared over second squared, and I eventually will take a square root, which will end up giving me meters per second. Now keep in mind that we're going to have a plus or minus because we're taking square root. Since I know I'm falling downwards, it has to be negative. So let's do this problem. Let's get out the calculator. Alrighty, so we're first going to do 2 times 9.8. Then we're going to multiply that by 20 and we will get our answer. Now the negatives cancel out and I need to take a square root. So if you take a square root, you end up with 19.8. Now my significant figures for this problem, again, only one sig fig. So my final velocity is negative 20 meters per second. Alrighty, that's all I've got for you. You guys have a fantastic day. See you in class.